So let's just try and move in and see what questions that you might have on some of the homework that I can help you work through. So were there things you can talk about, 1-1, 1-2, 1-3, any of those that you had questions on that you want to look at?
I had a hard time with on 1-1,
Okay.
number four, I think it was number 14 and 15. I did end up getting them right on the homework, but I don't know how. I don't know what I
Yeah,
did.
and that happens so often. So I appreciate your, candidness going, okay, I definitely want to know this better. Like I did it, but how I got to it, I'm not quite sure. So let's look at a couple of those. So you said like 14.
14 and 15 were the ones
Okay.
on 1-1.
Maybe let me try something here. Um, Still trying to figure out kind of the best way to do things on here, but I'll get better at it. All right, let me see if it'll just let me write in here. All right, so did it look something like this? Is this the question you're thinking of? That's what I saw for number 14.
Yeah, that's the one.
Okay,
Yeah.
all right. So remember there's a couple of things on here. Probably the easiest way to do these when you have your, we've got this square root graph. And we talked about yesterday how we know, a square root graph is going to kind of always have this shape to it. And so keep that in mind when you're thinking about what you're doing. And also, you sometimes on the homework, you're going to have to click on, which choice it is. If it's an x squared, you got to click on the parabola. If it's a straight line, you need to click on that one. So you got to remember that first of all, right, this is going to have that kind of a shape to it, this square root shape. And then one thing that is great to do is just to try and draw, just do a table of values and at least get a couple of different points here so you can see what the shape of it is and what's happening. And some people, and this was one of the questions that I think came up on the homework discussion that you guys were having, because some people were getting confused about this whole thing. If I put, numbers in here, some numbers are not going to work for one thing, right? So if I chose, if I tried to choose like x equals 0, well, I can't choose x equals 0 because when I do that, 0 minus 3 is -3. The square root of -3 is not a real number. All right, so I have to pick values that are 3 or bigger for one thing. So make sure that that is clear, that you need to do that. And then somebody tell me, how did you decide to pick, good values? Like, what do I mean by good values? I mean, values that are going to make this whole square root part a whole number instead of a decimal number. And somebody help explain that to the class, what you were thinking of there.
You have to come up with values that will make a perfect square.
Okay, so can you give me an example of one that you would pick?
The first one I would do would be 3.
Okay, I think that's a perfect one. I always think you always want to start with what would make this whole thing go to 0, right? So 3 minus 3 gives me 0. So I want to pick 3 as my x, right? But that's not what I'm going to get for my y, because notice I have this part, and maybe I'll extend this out so I can kind of show some work over here. Might make a little bit. So I'm putting 3 in there, right? And what am I putting it into? I'm putting it into all of this. All right, so I'm doing 1 plus the square root of 3 minus 3. So that part gives me 0. 1 plus 0 is 1. All right, so I found one of my points is 3 comma 1. All right, and so that's what I'm kind of doing on this. What would another good value for x be? Can somebody tell us?
7.
Okay, 7. Let's see what happens with 7, right? When I put 7 in there, so 1 plus the square root of 7 minus 3. Well, 7 minus 3 is 4, but the square root of 4 is 2, right? So I really have 1 plus 2. So make sure you're, thinking of that, and, maybe I shouldn't have skipped a step there, right? What I'm doing, but 1 plus 2, so I get 3 as my answer there, right? Whoops, I'm just going to put it here. All right, so 7 comma 3 is another point. All right, let's do maybe one more. Anybody have another suggestion of a point that would be good?
4.
Number 4.
Okay, yeah, 4 would be great too, because when we put that in, look what happens when we do the square root of 4 minus 3, right? That's 1, and then the square root of 1 is just 1. So 1 plus 1 gives me 2. So I've got the point 4 comma 2. All right, and then I have these 3 points here, and when you're graphing it on your homework, you usually only need 2 points. And even at that, I want to talk about that a little bit more too, because, and I'll try and pull up one of the homework questions to kind of actually look at so you can see, because there's something kind of tricky that you got to do there that some people discovered and we're helping other people out with it. All right, but if I plot these points on here, I have over 3 up 1, right, over 7 up 3. Whoops, what happened here? My blue pen went away. Okay, over 3 up 1, over 7 up 3, and then over 4 up 2. All right, so you can kind of see that it starts here, and remember there's nothing right to the left of this and nothing below that point. All right, so that's why it's always a good point to choose, all right, whatever is going to make that go to 0. And so it looks something kind of like this. And obviously when you use your graphing tool, it's, a lot nicer.
If you just use the first point and the last point, it won't work on the homework.
If you choose this one and this one?
Yeah.
You have to choose the first 2 points? Is that what you're saying?
I mean, it has to be the curve because it will think that it's like a straight line.
Well, usually there's a little key down there to pick what kind of graph you want, or sometimes it already has it on there.
Yeah.
So
I mean I know there is a key, but the program will think it's like a straight line and they will not get like all the points.
Yep.
I tried that and
it thought it was a line?
Yeah.
Okay.
Yeah. So there has to be a point that determines what the curve.
The shape of it is. Yeah,
Yes.
and I think that's just if it gives you all the different, I'm trying to see which question that was, because I know I know which one you're talking about. I just can't find it on. Oh, here's one. All right, let me see if I can, let me try and share this. Oh, that looks crazy. Sorry about that. It's because I went back to that screen, but this is what I wanted to show you. All right, can you guys see that? This is like right in the homework.
Yes.
Okay, just want to make sure that you're seeing the screen that I am seeing. All right, so when we have a question like this, notice that with the graphing, right, they give different options down here. You could choose either a straight line, a parabola, or this is an exponential graph. And so sometimes you have to know, like this is asking, which one is this? And so that's why they're giving you these choices down here, because you get to pick, right? So it is quadratic, right? And so that's why we'll pick this one. And so then when we graph it, just make sure to click on the parabola, because if you don't, then you definitely, like if we click on the linear one, and just didn't change that, then it's just going to make a straight line, right? But if we do this, then it will make a parabolic shape. So just watch that closely and make sure that that's what you're doing on those type. Okay. Actually, I guess I could have just moved that over here. Okay, so let's look at maybe, I know that there were people struggling. I think it was maybe question 9, right? And so, because there was just some issues with this, and even on mine, you can see I've got all of the questions correct, right? All of my ordered pairs there, but, it's saying that my, let's see, you guys can't see it anymore, can you? Just one second. Seeing the wrong thing, I think. Oh, man. Sorry. If ever you're like, what are you talking about, Becky? I don't see what you're seeing. Please just speak up. Okay, so hopefully you can see this one now. So do you see how it's showing me, and this was on question 9 on 1.1, that I have all of these points correct, but it's saying that this isn't correct, right? Does anybody have a suggestion on that? What might be happening there?
You had to put each of those points onto the parabola.
So you got to draw and plot each of those points there on this one. So that's what this dot here is for, right? And so on that one. But then there's other questions where they don't want the points, right? And so I know it gets a little bit confusing here, but notice what they're giving you down here, right? Whether they want you to use those points or not. Let's see. Somebody's saying maybe it was number 10. So
yeah, can you please check number 10? Because
yeah.
I did it like 100 times and I didn't know what was happening.
Yeah, so this one actually, and I think that somebody was saying on the discussion, notice that there are no points here on this graph. I think it was marking it wrong with the graph or with the points there. And I'm not sure exactly. I asked, somebody to look into it and see, but yeah, so some people were like, why is it, not showing it here? Let me just do a similar question and I'll show you what I mean. So on this, I want to make sure, again, I'm picking the parabola because it's an x squared graph, right? And then my highest point is 2. So, and you can just do a table of values to figure out some of these if you're not sure. And it looks like I got my point is not exactly there. And so sometimes it's really picky about that too. So try and make sure you're right there. And then, let's see, over 1, down 1. Should look about like that, all right? But notice that I didn't use this point thing, because if I try and use this and put the points on here, then it tends to mark it wrong for some reason. Oops, that looks really bad, but anyway, it's just, there's another point there. But see, if I submit the question there, right? And it's saying no. But if I clear all, I try this again and do up to, that again looks a little bit, down one, over one, about there. All right, and then I have it. And if you're like looking at yours going, I have tried this and it keeps looking the same to me, please, somebody sent me a screenshot of theirs and, said, I really can't see the difference here. And really it was just, that it was off by a little bit. And you can even see they give you a little bit of leeway there because that blue line is not right on my 2 like it should be. So it does give you a little bit of a leeway. But sometimes if it's off by a little bit more, it's going to mark it wrong. Okay.
So we don't have to point it, just to graph it.
Yeah, so this one you didn't need to do that. And I think the only way, to kind of tell the difference when it wants those points and not is, remember on number 9, it actually had you find those points. And then it gives the direction, plot the points, and then graph the parabola. Right? So this one's telling you you've got to put those points on, where the other one is just saying sketch the graph. So you'll figure out your table of values on your paper, and then you'll just pick 2 of those points to select to make your graph. Does that help a little bit? And
Yeah,
these are
thank you so much.
and these are really good questions to talk about right now because we're going to be doing a lot of graphing in this class. And so getting used to this graphing tool right now and figuring that out is so helpful. Any other things that you guys want to add, like maybe some things that you found helpful as you were going through some of the homework, especially with the graphing? That tend to be, I think everybody's sore spot that they were like, oh. But yeah, if you're really like struggling like on number 10 or number 9, you've tried doing the things that I said and it's still marking it wrong, you can just send me a screenshot of, what you put and what says the answer is and stuff, and that'll be great to me, and I can go in and change that for you, okay? But try these things out that I've said, because yeah, it'll, like I said, later on you're going to need to keep knowing these skills on how to use these on this computer. But I don't want you guys to get overwhelmed and frustrated by that. That's not my intent at all on these. Okay. All right. Anything else on 1.1?
I have a question.
Yeah.
It's not like any problem related, but for our like the stuff on Canvas, the homework stuff, is that counting towards our grade?
Yeah, this homework assignment that you're doing? Yeah, it is. So if you look on your syllabus, it kind of will break down what things, homework is worth 15% of your grade. So these homework assignments are definitely counting into your grade. Yeah, but you can kind of see the breakdown on all the different parts on the syllabus, what things are worth.
Sorry, I have a quick question too. So last class, you talked about how there was going to be like a participation survey.
Yeah.
So do we do that at the end of class, like on Thursdays?
Yeah, so they're always going to be due. They're going to be due on. Did I put them due on Friday or Saturday? I think I put them due on Fridays, just because. No, maybe I did Saturday. Yeah, Saturday, because I know there are going to be workshops on Friday, and that might be in the evening. So yeah, so every Saturday there'll be a little. So if you look go to the modules, I'll go there really quick so you can see. All right, so it just has participation week 1. All right. And then you'll just click on that and fill out that survey. It does show that it's due tomorrow. Okay, I'm going to change those. I want them due on Saturday, just in case some of you are trying to go to those Friday workshops. And I guess you technically have time to put those in, but you might forget. So I'll just change those to be due on Saturdays. But yeah.
And it's under quizzes. Sorry, I can't see. It's really tiny.
Oh, let's see. I know there's a way to make your screen a little bit bigger,
Maybe
but you can find them under quizzes, but really the best way to find everything is just under modules.
okay, and each week we'll have one of
Yeah,
those.
because then it's just kind of in order,
Okay.
and so after you do, all of this stuff, so this is where the participation week,
Okay.
yeah, comes in. But like I said, I'll change that so it's due on Saturday also. So you
Okay.
have
And
it.
do you know when those workshops are going to start?
I have not gotten any more information on it. Have you checked the website?
Yeah, the website shows that it's going to be on Wednesdays with Kevin, and I logged on yesterday, and there was like nothing to log, no link to the meeting.
No link yet? Okay.
Yeah.
I'll reach out to Kevin and just find out, and that way I'll
Okay.
know. So you guys will know when those are. Does it have a time for Friday yet? Did you notice?
It doesn't.
Okay. Because I think he was trying to figure out what time was going to work. So I'll email Kevin and ask him about that and send that out to you guys so you'll know.
Thanks.
All right. Okay, other things on homework. Did you guys want to look at anything in 1.2 or 1.3?
I guess kind of where I had some confusion was on the terminology as far as like writing stuff in like set builder notation or
Okay.
compound inequality.
Yeah.
But I'm sure we were going to go over that.
Yeah, and we will go through that today because there's two different types of notation. They'll ask you to write things in, and set builder is basically your inequality notation where you're going to be using less than and greater than signs, where interval notation you're using the brackets and the parentheses and stuff. So yeah, we're definitely going to go through some of those today. And so
Yeah, I was a little confused on when to use less than or greater than.
okay, yeah. Let's talk about maybe we could just even look at one of those. Was that there's stuff in 1.2, like with when you were writing the domain of it, is that what you're thinking of?
Yeah, that's what I'm thinking of.
Okay. Let's look. Okay, so let's look at this one, and maybe this will help you to kind of see. So notice that this is a line, but it's not a line that goes on forever, right? It's a line segment, meaning that it has some stopping points, right? The way you can tell if it goes on forever is it would have arrows at the end instead of those points at the end. Okay, and you got to watch that closely when you're looking for domain and range too. So on this one, right, so let's look at the domain written in interval notation. So remember with interval notation, we're always looking at the graph, right, the domain, we're always looking at the graph from smallest to biggest, so from left to right. That's our domain. All right, left to right. So furthest to the left is -3, but it doesn't include -3, right? And those of you that took 980 last semester might be a little bit more familiar with interval notation because they talked about that more than that set builder notation. All right, so parenthesis, if it doesn't include it, right, we'll use a bracket on this other end because it does include it. So keeping those two things straight in your mind too is really important. Okay, so -3, so parenthesis -3, comma, right, now how far to the right did it go? Well, it goes to 1, right? That's as far right as it goes. The graph is not going any further than 1, and it's also including 1. So I'll put comma 1, and then I'll use the bracket instead of the parenthesis. Okay. Is everybody okay there? If you haven't seen interval notation, for a long time or ever before, please speak up because there's a lot of people in your shoes and I want to make sure that's clear why we're using the parenthesis, why we're using the bracket. Okay, and that we're looking at it from left to right. All right, so then if I take this and now notice over here, it's saying, now let's write this in set builder form. All right, and it wants us to use a compound inequality. So that means we need to click on this part that says inequality, and it'll give us these less than, greater than, less than, equal to, greater than, equal to symbols for us to use. Okay, and what we want to say is that x is between -3 and 1. All right, all of our x values are between -3 and +1. And so we write that like this. So I'm going to write it down and then explain a little bit. So -3 is less than, all right, then I have x, which is less than or equal to 1. All right, now look at this statement here, right? Now forget about that 3 for just a second. If I could cover that -3 up, I would. I just want you to look at that x is less than 1, right? And that's true. Our x's have to be less than 1, all right? But also is true, and this is where it gets a little bit tricky, is when the x is written on the right-hand side of those inequalities, then it's really like you're reading those backwards. So this is really saying x is greater than -3, right? And that's true here, right? All of our x's have to be bigger than -3, right? So this is, and a better way to read something like this is x is between -3 and 1, including 1. And more often than not, the inequality signs go this direction, that less than direction, when you're writing them like that, than the other way. The other way just tends to be a little bit more, a little bit strange. You're kind of writing something a little bit different there. So if that helps you to think about it that way, that you'll probably be using these less than or equal to, depending on whether it has a filled in circle, we have to have the equal to part, the open circle, we have to have without the equal part. All right, what questions can I answer in that first, just that first part on the domain?
So we use the less than or equal to if there's a closed dot?
Yes, exactly. There's a closed dot because that means it includes it too. Where this is, the open dot is everything up to, but not including that point. So it's like, it goes up to -2.9999999999999, but it never gets to 3. Does that make sense?
Yes, it does. Thank you.
Yeah, you're welcome. Okay, so everybody take just a minute, and maybe some of you have already have done this, but write down what you think the range is going to be written in interval notation. All right, so what would the range on this be? All right, let's try this. So I want everybody to put your answer into the chat box. Don't hit enter quite yet because I want to give everybody a chance to get it put in there. All right, and then when I tell you to, they'll all kind of put that in together. All right, let's try that. So go ahead and hit enter if you haven't yet. Okay, that's looking really good. All right, so most of you are saying that it is a bracket, right, that you need on there, then -3 to 2, and then parenthesis. All right, so because remember, you're looking at it from bottom to top, smallest numbers to biggest numbers. That's one of the things that people, tend to put in backwards, like they'll put from 2 to -3, but we always want to go from smallest to biggest. And so you'll miss it if you're putting it in backwards that way. All right, and then on this one, right, y needs to be between -3 and 2. So I'll say -3.
I have a question.
Yeah, you bet.
So why is it 2 instead of 1 when 2 is would just be less than?
So it
'Cause
doesn't,
it's not less than or equal to?
yeah, so do you see that like there's still all of these values between 1 and 2? So it couldn't be 1,
okay.
right? But it's because it's going to be up to 1.9999999999999, right? Just not 2. So that's how we distinguish it and say it's up to 2, but not including it.
Okay, perfect.
Okay. Okay, good question. All right, and then we need to do the equal to part on this one, right? So we got -3, that's our lowest point, and it's filled in, so we got the equal to. And then we want to use y on this one because these are our y values. And then is less than 2, all right? Because notice at 2, right, it's an open circle, so that's why we're using the less than symbol on that. Okay, I can submit those, make sure we did those all correct. Awesome. Okay. All right, I'm sorry if that's really small for you guys to see. I'll see if I can't try and figure out a way to get these bigger. I think there is some kind of a something on your screen that will make it a little bit bigger at least. It's that same kind of, it's like the arrows going out or something like that. So look for that too, because that might help. All right, any other questions on those, the domain and range and being able to use these different type of notations and knowing which notation to use when? These have all been great questions. I really appreciate you guys bringing your questions that you have because we have the time in class now to talk about it, so we definitely want to do that. All right. Okay, anything on 1.3 that came up that you want to look at? Okay, well, I think what we're going to do then is I'm going to give you a little bit, just kind of like a little mini lesson here, and we'll talk about, you said, like some of the terminology and stuff like that that maybe, was an issue on some of these things that came up. But so I want to first of all talk about functions. And so remember, with functions, you've got to know what the domain is. All right, and that's the set of all x values. And then the range is the set of all y's. Okay, and a function, all right, is a relation or a correspondence, if you want to call it that, either one is fine, a relation where the x values are not repeated. Okay, and I'm going to give this, I mean, this is just kind of the it's the non-technical way to say what a function is, right? Because like I said, like when you look in the book for what the, what a function is, right? They say that, every value in the domain, right, has only one value in the range. And so that kind of gets a little bit confusing for some people. But so I want you to think of it this way though, because if we had the numbers like the points 1, 2, all right, here's a relation here, and -2, 2, and 4, 1, and then 1, 2. All right, so I want to point out that even though this x value is repeated over here, it has the same y value because it's the exact same point. And so this still would be considered a function. That's one of the things that a lot of people get confused about, going, well, wait a minute, that 1 was repeated, and so it's not a function. And that's just because this is kind of a, it's not the most technical definition for function, but it helps a lot of people to be able to, in their mind, be able to determine if something's a function or not. So if you're going to use this definition, you've just got to remember that if the x repeats, then the y has to be exactly the same, right? So that it is that same point, and then that would still be a function. Okay. But let me give you a little analogy that I like to talk about with when I'm dealing with functions. Okay, so I am going to draw, this is a vending machine, okay? This is a beautiful vending machine. Okay, and A1, all right, is going to be one thing. So somebody just tell me what's one thing that you might find in a vending machine? Like whether it's like a specific
Diet Coke.
Ooh, Diet Coke. Yes. Are you the one that said you're addicted to Diet Coke? Because
Yep.
me too. And even more so when I put like, and I like putting flavorings in it too. But,
oh, me too. Lime and coconut.
yes. All right, so A1 is going to represent Diet Coke. All right, and this is going to be maybe a strange vending machine because we're going to have all these different things that might not technically be in the same vending machine, but somebody else yell out something else that might be in a vending machine. Oh, somebody said a cookie. Okay, like maybe one of those grandma cookies or granny cookies, right, with the pink frosting or whatever. Sometimes those are in there. Okay, what's something else? I need a few more. We got to have 6 of them or so in here.
Chips.
Okay, chips. Awesome. What else?
Gum.
Root beer.
Okay, then I heard root beer. Okay, and give me one more.
Water.
What was that?
Water.
Water. Okay, awesome. Okay, so there's all these different things that you might find in a vending machine. And I want to show you how a vending machine is like a function, right? Because it helps people to like be able to really solidify what's happening with functions, right? So remember that every single thing in the vending machine has a specific number that's corresponding to it, right? And so if you click on A1, you expect a Diet Coke to come out, right? Where what if you, let's see, I'll just kind of erase this for a second here. So what if this said A1 also, right? So Diet Coke is A1 and chips are A1. Well, you're not going to get both of those, but you'll get one or the other. Do you know which one you would get if that's the case?
No.
You don't. And I'm here to tell you, I would be really bummed if I clicked on A1 and I didn't get my Diet Coke.
Same.
Right? If chips came out, I'd be like, oh no. Right? So we want to know, like, when we're punching something into that vending machine, what we're getting out. Right? So that's kind of what's happening here. When I, punch 1 into the function, I know 2 is coming out. When I put -2 into the function, I know 2 is coming out. When I put 4 into the function, I know 1 is coming out. All right, so that's kind of how these are related to what's happening here, right? Now, what about this? So what if we had, and maybe you've seen, some vending machines before where, so A1 is water, right? A2 is water. A3 is water. A4 is water. All right. So would this make a function or not?
Yes, it would, because the values on the y are all the same, or like what you choose. What you get is going to be the same no matter what.
Okay. So let me maybe say that just a little bit different and see if this is what you're saying. So when you punch in A1, do you know what you're going to get?
Yes.
When you punch in A2, do you know what you're going to get? A3, A4, right? So notice that what you're punching in is unique. It just happens to be that anything you pick, water is going to come out. Right? And that's like having, something like this. If I had, 1, 3, 2, 3, 3, 3, 4, 3, right? It's still a function because notice my x values are unique. It doesn't matter that my y values are the same. It doesn't matter that water, comes out. And all of that, okay? So now what if you had, the same kind of a machine, right? But what if, whoops, that's not what I meant to do. What if this says A2 and this one says A2, right? Is that a function?
Yes, it still is because the y's are also the same. It's the same
Yes.
point.
It's the same point. Exactly. So that's what we had going on up here. Remember I said if you're clicking on A2, water's going to come out. Well, if you click on A2 here, also water comes out, right? So that is a function. It's not a function if something different comes out, right? If we're looking at getting a Diet Coke compared to chips, right? That's when it's not a function. When you put something, punch something in and you don't know what you're going to get out, like there's more than one possibility of what can come out, that is not a function. Okay, does that help you guys to kind of visualize what's happening with functions?
Yeah, that's really helpful.
Okay, good. Because we're going to talk about functions a ton in this class. And so making sure that you really are, have a good grasp about what a function is and what it isn't is super important. Okay. All right. Okay. Let's maybe do this. I think we are about halfway through class right now, so I want to take just a little 5-minute break. I like to do that just because you need to get up, get a little bit of oxygen, right? Step away from math for a minute. So, so let's take a little 5-minute break, and then when we come back, I'll continue talking a little bit more about 1.2 and 1.3. Okay, so come back at 3:05. Make sure you're back at 3:05. All right, so I want to talk a little bit about a few things in 1.3 also that you may have came across or maybe had some questions on. But just to clarify a few things too that you talked about in this. So first of all, lines, linear equations, I guess is another way to say this, right? Linear equations can be written in a lot of different ways, right? The equation for them can be written in what we call standard form, which is where you have your x's and y's on one side of the equal sign, and then your whole number is on the other side there, right? So that's standard form. And we don't usually, standard form is helpful for some things, but usually the form that we like to use is slope-intercept form. And that's because we can easily pick out the slope, we can easily pick out the y-intercept, right? So that's why we like this form. So it says, it's just that y equals mx plus b. All right, where m is the slope and b is the y-intercept. Right? And also b is also sometimes called the start amount. So I'm going to just write that above here too. Because when we're dealing with word problems, and in 1.3 we have some application problems, and it's really good to know, okay, what is the start amount? What is the beginning amount that they're talking about in that? That is your y-intercept, okay? So, so these two different forms, and if it asks you to find the slope and the y-intercept, but it's in standard form, then you need to solve it for y. You got to get y by itself so that it looks like this. All right, so when it's in this form, I can't just say the number in front of my x is going to be my slope. All right, that's true here when it's in this form, but not in this form. Okay, we gotta rearrange that around first before we can figure those things out. Okay, so make sure you're clear on that about those two different types. Also, and it looks like most of you are good with the slope formula, right, which is m equals y2 minus y1 over x2 minus x1. So notice that it's the change in y's over the change in x. That's our slope, right? And remember, the y's are the up and down. So that's we call the rise. And then the x's go left to right, and so we call that the run. So you also hear slope called rise over run, right? So change in y over change in x. You'll hear this a lot more, like if any of you are going to be taking physics or something like that, you'll usually hear it kind of more this way. But I think it makes a lot of sense to talk about it in math and understand the applications, the application problems with this to understand the slope better. So I just want to make sure that you're seeing that. Okay. Also remember with slope, right? A couple of things, more things I want to make sure you're thinking of here. What kind of a slope does this line have? imagine that it's perfectly horizontal.
Has a zero slope.
Okay, so that is a zero slope. Okay, now you can't say no slope, right? If you say on a test or something this has no slope, you will miss it because the slope is zero. If you're looking at the change in y compared to the change in x, right? It's not changing, right? There. But the other one to compare it with is this kind of a line. So if you have a straight up and down vertical line, what kind of slope does this one have?
Undefined.
Yep.
No slope.
So again, you can't say no slope because both of these could mean no slope. Do you see that? So yeah, but I know what you're meaning. I know you're thinking, well, it's one or the other, but I just want to make sure it's clear. Be really specific. Do you mean zero slope or do you mean undefined? Right? And why is this undefined? Well, it's because when you do the slope formula on this, right, when you try and find your slope is like some number divided by 0. Well, what happens when you try and do this in your calculator? If you do 3 divided by 0, what does it say?
You get a divide by 0 error.
Yeah. And so some calculators will just say error. Everybody kind of says it a little bit different, but it won't give you an answer, right? And that's because we can't divide by 0. So that's what's happening on these lines, right? Because our change, as we're going, notice our run, right? It's not moving left or right any. That's where that 0 is coming from. All right. Okay. All right. And then maybe to remember with these, if you have a line, so horizontal lines are always going to be something that looks like y equals some number, right? So like if I have y equals -2, this is the equation of that line. Right? And so I know sometimes people get confused by that going, well, that just looks like it's part of a point, but you'll see that lines will be written like this. And you'll also see lines, equations of vertical lines will be written as like x equals some number, right? So if you have like x equals +3, right? That is undefined slope and it's a vertical line. Okay, so kind of keeping those two things straight in your mind is helpful. And one person told me that they remembered, that the straight up and down is undefined is just because they just said, well, what if, you're walking across and then all of a sudden, or no, I think they were talking about skiing actually, skiing somewhere and then, all of a sudden you have the straight drop off, right? And you're like, okay, I would be undefined no longer, or, I will be no more. I will be undefined. All right. So anyway, they just kind of had a silly way to think of it, but that's always a good thing to try and do. Come up with those ways that will help you. Okay. All right. What about, I want to talk about, and this is something that I'm not going to go on it too much. You should have gotten it in the videos a little bit there. So parallel lines and perpendicular lines. All right. We talked about these. So parallel lines look something like this. All right. So what do we know about the slopes of parallel lines?
They're the same.
They are the same. Okay, so I'm going to put down that they have the same slope. All right, so perpendicular lines intersect each other at 90-degree angles. They have to be intersecting in a very specific way, right? It couldn't just be any two lines intersecting haphazardly. All right, they have to intersect at 90-degree angles. And if they do that, we also know something about their slopes. Does anybody remember what that is?
Negative reciprocal.
Okay, so slopes are negative reciprocals. All right, or sometimes called opposite reciprocals, whichever way it resonates best with you. But the whole point of this is remembering that if you're finding the slope, so say that I have one line, right? So slope of one line is -3. Well, the perpendicular slope you have to change the sign and flip it, right? Reciprocal means that you're flipping it, and either the negative or opposite. It's not always going to be a negative answer. That negative just means change it to its opposite. So that's why I said sometimes you'll just hear it called that. But whichever way sticks best in your brain is what I want you to use. So if we change the sign, it's going to be 3, and then I flip it, it would be 1/3. All right, so these two lines, if I had a line with a slope of -3 and a line of a slope of 1/3, they would intersect each other so that they meet at 90-degree angles. Okay, so that's an important thing to keep in mind with these parallel and perpendicular lines. All right, then I also want to talk about x-intercepts and y-intercepts, because this tends to be a sticky thing for some people, and they don't really understand what you're finding here. Write this down. And I like to use graphs just because it's a little bit easier, right, to tell what is happening on this. So let's see. That I've got a graph that looks something like this. Okay, and when I'm trying to find my x-intercepts, I'm going to let x equal 0. Oops. Whoops, sorry, I meant y. I don't know why I said x. Okay, let y equal 0 and solve for x. All right, so this is if you're given an equation, that's what we'd want to do. All right, if we're looking at a graph here, well, let's look at this. Let y equal 0. Well, here are my y's, right? The straight up and down, my y-axis, right? And when y equals 0, right, then what are my x-intercepts going to be? So I'm thinking of across here, right? This is where y is 0. Everybody see that? Because here it'd be like -3, -3, -2, -1, 0, 1, 2, 3, and so on, right? So I want to know when it's 0, or when y is 0, what is my x? Well, my x's would be these 2 points, right? And so then on this graph, I would say that my x-intercepts, right, I'd have more than one, are going to be maybe -1, 0, and 1, 0. Right? So when my y is 0, what are my x's? And then the y-intercepts are just kind of the other way around. It's saying, you know, when let's let y or x equal 0 and then solve for y. Right? So you'll do the solving part if you're given an equation, which most of the time you are given an equation more often than you're given a graph when they're asking you to do this. But I want you to see it graphically too. So when x equals 0, remember this is our x-axis, right? So all of these numbers going here, right? And so on this, right now I'm looking at this one. This is where x is 0, right? Well, when x is 0, what is y? Right there at -2, right? So my y-intercept would be the point 0, -2. Right? All right. Any questions? I want you guys to speak up. Any questions that have come up so far on this? Things that you want clarified a little bit better? And like I said, those of you that took 980, this should look like a little bit of a review for you, but those of you that haven't been in math for a while, you'll be very thankful for this review, right, in this first chapter here, or part of the first chapter. All right, then maybe the last thing that I want to talk about before we get you into groups is writing an equation of a line. All right, so you're asked to write an equation of a line, and there's two different ways that you can do this. And I am fine with either way that you choose to do it, because maybe in 980 you were taught one way and you're like, I like that way, or you just remember something from, high school or something that you're like, yeah, I really liked that way, and so I want to keep using it. So that's fine. So there's two different formulas you could use. So I'm going to show an example of this where we're just using this one formula, just the slope-intercept form, right? The other one, this is called the point-slope formula. Oops, formula. And that's because you need a point and a slope to use it. And it says y minus y1 equals m times x minus x1. All right, so you can use either of these two things. And I'll show you kind of both ways on this, how you might be able to write an equation of a line using these, okay? So I want to write an equation of a line, and let's do maybe I'm getting ahead of myself here on this. Thought it was part of this. You know what? I think we're going to wait on that. We're going to cover next time. Sorry, I was thinking that we wanted to talk about this already. So, but that's okay, because that will give us the time that I was hoping that we would have for the little breakout sessions too. So I'll keep you posted on this. We'll come back to that and talk about it next time with how to write these equations of lines, okay? But, oh, wait a minute though. Oh, you need to know how to do it for the review that we're doing. So let's try one of these. So let's say write an equation of a line that's through the point hold on a second. Now I've got to make sure I want to have ones that work out a little bit nicer here for us so that's not so crazy. All right, so let's do write an equation of a line that is going through the point 2, 5 and is perpendicular to this equation, x minus 2y equals 3. Okay, so remember, in order to write an equation of a line, right, we want to know what the slope is, right, and we want to know what the y-intercept is. Okay. And starting off, we don't really have either of those two things here on this. I don't know what the slope is quite yet because my equation isn't written in slope-intercept form. So that's the first thing that I'm going to do, is I want to change that into slope-intercept form. And so I'm going to get y by itself. So I'll start by subtracting the x over. So I got negative 2y equals negative x plus 3. And then I'll divide by negative 2. All right, divide everything by negative 2. And then here I get y equals 1/2, right? Negative divided by a negative is positive. 1/2 x, and then a positive divided by a negative is a negative, so minus 3/2. Okay, but the only part of this equation that I care about is the slope. That didn't look so good. It's hard to read it now. Oops. All right, so just this 1/2, right, is what I want. That is my slope. So I'm going to just put m equals that. All right, and so I know my slope, and I know an x and a y. That's these. And so I'm going to put those x and y in place of the x and y in my equation here. All right, so when I rewrite this equation, in place of y, I'm going to put 5, and then equals the slope, which is 1/2, right, times my x, which is 2, and then plus b. And so all I have left to solve for is that variable of b. All right, put in everything else that I had there. So now let's simplify it and solve it so that b is by itself. Well, 1/2 times 2, or 2/1, right, just gives me 1. So I really have 5 equals 1 plus b. And then I can subtract the 1 over. So I get b equals 4. Right? And so now this is, right, I know what my slope is, and now I just found my y-intercept. And so now I can use both of those things to put it into an equation, right? I'm not done yet because I haven't written an equation of a line yet. So let's do that. So I get y equals, right? I'm going to put it in this y equals mx plus b form. My slope is 1/2. Okay. 1/2 x plus my b is 4. Okay. And so that would be my answer. That is the equation of a line that goes through this point and is perpendicular to this. So some of you might be looking at this going, wait a minute, we didn't have anything on it yet. And it looks like we didn't yet, so I'm kind of surprised it was on this weekly review. One of the other instructors made these weekly reviews, but that's okay. We'll talk about it a little bit, and I think you'll be able to do this. And then the other way you can do it is to use the point slope formula. So again, you'd still have to do this part in orange here where you're figuring out what the slope is, but then you put it into this formula. Right? So I have y minus y1, which is my 5. So y minus 5 equals m, which is my 1/2, x minus x1, which in this one is 2. Okay. So I'm just putting those things in. And then basically you're just kind of rearranging this, right? So you've got to distribute that through. So I get y minus 5 equals 1/2 x, and then you're going to distribute that through 1/2 times negative 2 is a negative 1. And then I need to add my 5 over because I want it in that y equals mx plus b form. So y equals 1/2 x plus 4. All right? And so then again, I can see here's my slope and here's my y-intercept.
You said you don't care which way we do it?
Yep, I don't care which way you do it.
Okay.
So either way is perfectly great for me. I'm never going to say you have to do it one way or you have to do it the other way. So yeah, I'm glad you asked that.
Shouldn't the slope be -2?
Uh-oh, let's see what happened.
Just because perpendicular.
Oh, yes, I did the one for parallel. Thank you so much. All right, I totally forgot about my word perpendicular, right? So I guess what we just did here was for parallel. If it said for a parallel line, right? But then, yeah, so if we wanted the perpendicular, right, we'd have to flip it and change the sign. So you could try that also. So let me just write that here. The perpendicular slope, this is just a little symbol for perpendicular, would be -2. Okay, so if you wanted to find the perpendicular, which is what I asked originally, but we'll just say parallel, then you would use -2 everywhere I put the 1/2 instead. Okay, thank you so much for saying that, because people could be getting confused going, wait a minute, I thought she said we had to do the opposite reciprocal. You do. You definitely do. Thank you. Okay, I'm glad. Some of you said that in the chat, but sometimes I just don't see the chat. It doesn't alert me that you've said something there. So yeah, glad you spoke up. Okay, well, I want you guys to have some time to work on the weekly review thing together. So let me show you. I know last time there was an issue with trying to get, like, you couldn't see the document and stuff like that. I mean, the weekly reviews are on Canvas, so some of you could pull it up from that also. But also, you could, on here, let's see here.